All right, guys, on this video, we're going to work backwards. All right, so most of what we've been doing is we've been finding the zeros. We are given a polynomial with f of x, and then we try to find zeros using synthetic division or using the TI inspire. Okay, you guys can take this down in your notes. So now, let me mark up on this. This is what we can take down. Now we're going to switch it up. We're going to be given the zeros, but we're not going to be given f of x, but we're going to use the zeros to get us f of x. And we're pretty much going to rely on factor theorem. All right, so you're going to see how we're going to work backwards. Okay, so let's look at this. I guess this continued with the notes from the problems with finding the TI inspires using, or finding zeros using the TI inspire. I think there was 4 problems on this. That's why this starts with 5. All right, this one says find a polynomial function f of x has a degree of 3 with -2, 0, and 3 as the zeros. So that kind of makes sense. Our degree is going to be 3, and we have these 3 zeros. All right, now as I said, we really rely on factor theorem. So if this -2 is, if that's a 0, then its factor is, remember we say x minus k? So it's x minus -2, which turns out being x plus 2. Now, if this 0 is a factor, well, if you said x minus 0, that's just x. And then if 3 is a 0, then x minus 3 is a factor. All right, so we're kind of working backwards with the factor theorem. Then once you have that up, all the factors, we just have to multiply everything. I have to FOIL everything out. Now, the easiest thing to do, if you have 0 as a 0, this x, always write that first, and you deal with that at the end. The last thing we're going to do is distribute the x. So I'm just going to FOIL out this x plus 2 and x minus 3. So this is going to give us what, x squared. The outer term's -3x. I'll just write it here. The inner term's positive 2x. So when you combine that, we get minus x. And then 2 times -3 is -6. Okay, then last thing, we distribute that x, and it's going to give us the degree of 3. So x times x squared is x cubed. X times this negative x is negative x squared. And x times this -6 is -6x. And that's our answer right there. All right, so this is the function of x. Now, how can you check that this is right? If you graph this, you would see that this graph would hit the x-axis at these 3 x values, -2, 0, and 3. All right, let's do one more on this video. Okay, so this is number 6. Now, one typo, you can see it says coefficient of 2. It should be 3, right? That's a typo. So this one, it's saying find a polynomial function has that leading coefficient of 3, but has a degree of 4. So what that means is our first term should be 3x to the 4th. And it gives us 4 zeros. It gives us -2, -1, 0, and then it gives us this fraction of 1/3, which is a little bit different. All right, this 0, again, that's just x. So let's write out the factors. Let's use the factor theorem. -2, just like the last one, if that's a 0, well, I'll put x for the 0 as a 0. If -2 is a factor, then we get x plus 2, as I said, just like the last one. If -1 is a factor, then x minus -1 or x plus 1, that's a factor. Now, this could be a little bit tricky, 1/3. Now, if I just straight up use the factor theorem, I would have x minus 1/3. But we do not want to FOIL out 1/3. It's going to make it a mess. And whenever we deal with polynomial functions, we never have fractions in it. We always have integers. So what we would do is I would just distribute 3. Whatever the bottom number is to get rid of that fraction. So if I distribute 3, I'm going to get what? 3 times x. And then 3 times -1/3 is -1. Now you can see if you still set this equal to 0, 3x minus 1 equal to 0, you would get 1/3. And the other thing is, it has coefficient of 3. Well, that's how we get the coefficient of 3 right there. All right. Then it's a little bit tedious, but then you just have to FOIL out. The bigger the degree is, the more you have to FOIL out, distribute, and combine like terms. What I'll do is I'll group these two together. You can go in any order that you want. You just still end up with the same fourth degree polynomial. So if I distribute the x plus 1, 3x minus 1, let's see, I'm going to get 3x squared. I'll write up here the outer term's minus 1x. The inner term here is positive 3x. So when I combine that, I get plus 2x. And then 1 times negative 1 is negative 1. Okay. Let's see here. Well, let's say I multiply these. We could do this many different ways. But if I distribute the x, I'm going to get x squared. X times 2 is plus 2x. Okay. And then this is the part where it just gets a little, as I said, a little tedious. You have a lot of work. This is where I'm going to distribute this x squared to all three of these terms. All right. So we just have to kind of be patient, take your time, make sure you show all the work. It's not hard, it's just a lot of steps right here. All right, so this x squared times 3x squared is 3x to the fourth. That's going to be your leading coefficient. Then x squared times 2x is 2x cubed. And then x squared times negative 1 is negative x squared. All right. Then we're going to distribute this 2x to this 3x squared plus 2x minus 1. So then 2x times 3x squared is 6x cubed. 2x times 2x is 4x squared. And then 2x times negative 1 is negative 2x. All right. Then the last thing, we're just going to combine like terms. There's no other x to the fourth, so we bring this down. So 3x to the fourth, I'm done with that. All the x cubes, we have 2x cubed and we have 6x cubed. So we combine those, we get 8x cubed. Done with that. Then let's look all the x squareds. I have negative x squared and plus 4x squared. So negative 1 plus 4 is 3. So we're going to get plus 3x squared. Done with that. And then this is the only term we're left with. There's no other x's, so we just bring this down. So it's minus 2x. All right, so we get 3x to the fourth plus 8x cubed plus 3x squared minus 2x. This is the answer right here. All right. Now, if you kind of looked at each step, it's really not that hard. It's just a lot of steps. As long as you're patient with it, show all the steps, FOIL everything out, combine your like terms. Okay, these problems shouldn't be too bad.